Okay, we're going to work on a few topics here from Unit 5. So these are all Unit 5 topics. And the one we're going to start with here, this topic number 1, it says find all excluded values for the expression. So that's what we're going to be doing on topics 1 through 3, finding excluded values. Those excluded values are numbers that would be not possible if we plugged in for either of these v's in this problem right here, either one of those. It would basically make it undefined. Yeah, it says it right there, I guess. It makes the expression undefined or not possible. The calculator wouldn't calculate it. So how would we be able to find those numbers? Well, those numbers are going to be anytime we have a zero on the bottom of a fraction. So you can't take any number and divide it by zero. For example, 8 divided by zero is not possible. That's undefined. So if we can figure out what would make this bottom turn into a zero, like if we could get 3v plus 6 to equal 0, then that would be when this is undefined. So we can take it and we can set it up. 3v plus 6, we can set that equal to 0. And now if we solve for v, we should be able to figure out what would make that equal 0. So if I subtract 6, 3v equals negative 6, divide by 3, we get v equals negative 2. And so therefore, if we plugged in a negative 2 for v, that would equal 0. We can't have 0 on the bottom of a fraction, so that would make it undefined. That's topic 1. Topic 2, the directions got cut out on this one, so I just wrote it down real quick. We're still looking for what would make this undefined or impossible to solve, basically. So I'm looking for a number that I can put in for either of any of those v's, and it would make it undefined or not possible to solve. So again, we're looking to figure out what would make this bottom part equal 0. So I don't really care what's on the top. I could actually erase it if I really wanted to. I probably won't do that for the sake of the problem, but if I wanted to erase it, I could. So if I'm trying to figure out what would make that equal 0, what I'm going to do is I'm going to factor these. Okay, so I'm going to factor that bottom. So v squared plus 2v plus 1. I need two numbers that multiply to give me 1 and add to give me 2. That's going to be a 1 and another 1. And so the v's will go up there. We're going to need both of these to be positive in order to add to equal 2. And then I'm going to look at both of these options here. Now, these two options are exactly the same, but you might have two different options that you'd have to look at. And I'm trying to figure out what would make each of those parentheses equal 0. Well, for both of these, a negative 1 would cancel them out. So sometimes you might get two answers. I think you separate it with a comma when you type it into Alex. But in this case, we only got one answer. All right, let's move on to topic 3. All right, topic number 3. Same situation here. We're trying to separate this bottom piece here. That's what we care most about right now, that bottom piece. If we can separate that and factor it into two separate pieces and then set it equal to 0, we're going to be able to, well, this is a kind of, the directions read kind of differently, but we're doing the same thing essentially. We're trying to find the values of x that are not in the domain. We're trying to find basically the x values that will not work for this problem. So x squared minus 81, if we set that equal to 0, we're trying to figure out how to make those equal 0. Well, this one is kind of special because it's a difference of squares. So when I break it apart like that, and I know 81 is a perfect square, separates into 9 and 9, and with a difference of squares, I need a positive and a negative. Therefore, my two separate answers for this will be, well, for this first one, a negative 9 would make it equal 0. I don't know why I put a 1. I meant a 9. That would make it equal 0. And for this one, a positive 9 would make it equal 0. So those are my two answers that I'll type into Alex. Topic number 4. Okay, so for this one, we're just simplifying. That's all it says. We're trying to make this as simple as possible. So when I look at this, what I notice right off the bat is that we have 3 groups being multiplied on top and 2 being multiplied on the bottom. What I mean is we have this, and we have that. And on bottom, we have this and this. Now, when all those things are being multiplied, all we need to do is cancel the ones that look alike. So, for example, on this one, u plus 8 and u plus 8 look alike. So those can be canceled. And then also 6 over 24 can be canceled down to 1/4. Then what are we left with? We've got this 3u plus 4. That can go on top. Not going to do anything with it. And then if I wanted to make this look prettier, I know that I don't really need the 1 on top, so I could just open up that parenthesis and call it 3u plus 4 over 4. Now, I have some students that might think you should cancel out the 4's, but really this 3u is being divided by 4 as well. So we can't cancel out those two 4's, the one on top and the one on bottom, because then we're getting rid of the 4 on bottom for the 3u. So that's your final answer for number 4. Going through topic number 5. Okay, so for topic number 5, I'm going to first try to pull something out if possible, because I'm noticing on the top and the bottom I can pull something out. So I'm going to pull out a 7 out of the top. That'll leave me with, I actually can pull out more than just a 7. I can pull out a 7 and a y from both of those terms. That'll leave me with a y minus 5. And then on the bottom, I could pull out a 4. I could also pull out a y, and that will also leave me with y minus 5 if I pulled those out. Now at this point, you can probably tell where we're going with this. I can cancel out the y minus 5. And then something that sometimes people forget to do, we can actually cancel out these y's as well. There's a y on top and a y on bottom. So those can go away. And so that'll just leave me with 7 over 4. That's kind of tricky. If you have questions with that, make sure you let me know. Number 6. Okay, so number 6, there's really 3 possible answers for this one. You can either get a -1 as your answer, you can get a 1, or you could get cannot be simplified, and I'll abbreviate that for this purpose. So let's kind of go through this here and see if we can simplify these things. I noticed right off the bat with this problem, I could rewrite that. Since it's an addition sign on the bottom, I could rewrite that as 2x plus 7 over 2x plus 7. And now they look the same. I mean, originally they were technically the same. They were just, one was flipped around. But now they even look the same. And so these will both cancel, and we'll just be left with 1 for that first one. For this bottom one, it's a little tricky. I see there's a 2 on the top and the bottom. I see there's an x on the top and the bottom. And I also see that there's a 3 on the top and the bottom. But the problem is we can't cancel a 2x with a 3x. That doesn't work. So this one is going to be not possible or cannot be simplified. That technically is simplified all the way. Even if you flip things around, it's not really going to work. It tried to trick you by saying the 2x and the 3x. It looked like they were maybe cancelable, but they're not. Let's go on to 7. Topic number 7. What can I pull out from the top first, if anything? If I look at that, I don't see anything can be pulled out. So then I'm just going to go into factoring mode. So if I factor the top piece, I know I'll have y and y. On the bottom, I don't think I'm going to be able to factor, so I'm just going to put that y plus 2 down there for now. Now let's look at two numbers that multiply to give me 4 and then add to give me 4. That would be 2 and 2. They're both going to be positive. And so now what I'm looking, and sometimes it helps if I put parentheses around it, even though it's not necessary, just to kind of see if you can find any matches. In this case, we obviously have a match. It doesn't matter which one we cancel out on top, but if I cancel that one and that one, that means all we have left is y plus 2 for topic number 7. Topic number 8. Looks like we're going to have to do a little bit of extra factoring on this one. Now we're getting into some situations where we're going to have to work a little bit harder to factor that top piece because it's got an a value attached to it. And for this one, you might be able to figure it out in your head, but I'm going to go through it the old-fashioned way. It's a little bit of work, but it'll work for every single question. So that's how I'm going to go through it here. Let's see. So I'm going to do A, C, and B. I know that they have to multiply to get AC and add to get B. My AC would be my A value times my C value, which is a -8. And then my B value, which is -2. And then I need two numbers that multiply to give me negative 8 and add to give me negative 2. I think that would be a negative 4 and a positive 2. Then I can split that up, the top value or the top equation there. So 2y squared minus 4y plus 2y minus 4. I can group them. I can pull out a 2 and a y from the first group. That'll leave me with y minus 2. And in the back group, I can pull out a 2. That'll leave me with y minus 2. So my factored form would be y minus 2 and 2y plus 2. And those factoring, more examples of this factoring are in Unit 1, so you'd have to look back there for extra examples. Sorry about that. You'll have to look back there for extra examples of that. On the bottom, that one we should be able to factor. So that was the top of my fraction. I'm just going to put my fraction bar here. On the bottom, that's pretty easy to factor because it doesn't have an a value. So I can go y and y. And then two numbers that multiply, that give me negative 6, but add to give me a positive 1. That's going to be a negative 2 and a positive 3. And then at this point, as I'm looking at my fraction over here, I can see that two of these are going to cancel out, those two right there. That will leave me with 2y plus 2 over y plus 3. And there's nothing really else I can do to simplify those. So that is it for topic number 8, and that's where I am going to call it today.